The rest of this block is what you might call a masterclass. It applies techniques we've already learnt in a larger problem. And the thing we're going to look at is what's called language processing. There's a link to the code I'm developing here, so that you can get hold of a copy of that. So what I'm hoping you'll learn from this is seeing ways of using data types to represent structured data. We've seen a little bit of this, but this is giving a much bigger example. And once we have that, the different ways that we can process that structured data. We'll use type synonyms, but we'll also use algebraic types in thinking about those representations. And what we'll do is build a suite of functions that work over a particular type, which is really an API for that type. And also you'll get a chance to think about ways you might extend an existing program when I give you some directions for further developing the code that's put in front of you. The general area of this is language processing. Little languages appear in all sorts of places when we work in computing. XML, SOAP, REST, HTML5, all sorts of things like that are languages for which you might have to write a small processor to understand or to transform or to output data in a format like that. You also find languages in text processing, in system build and configuration files and so on, in data analytics, in testing, and in what are called domain-specific languages. So all these areas are where you get formal artificial languages are processed beyond the good old example of compilers. Probably most people don't get to write a compiler in their life, but most people do get to deal with a small language. And so an example like this is indicative of the sorts of problem you might have or might have to deal with when you're programming. The little language I'm thinking about is a language of numerical expressions. So things like 2 plus 3 times 4, or 2 plus 3 times v, where v is a variable. So we're going to work with that kind of language. Now, the first question you might ask, and when you're thinking about programming, building a set of functions to work with expressions, what sorts of things can we do with expressions? Well, we can evaluate them. If I have an expression like 2 plus 3 times 4, that has the value 14. And I can also evaluate variables, I can evaluate expressions that contain variables as long as I know how to interpret the variables. I can simplify expressions. This isn't the same as evaluation. So if I have an expression 0 plus 1 times v, well, 1 times v simplifies to v, and 0 plus v simplifies to v2. So you can simplify them symbolically without evaluating them. That's a different process. We can compile them. So we'll see, I'll show you a small virtual machine for evaluating these expressions, and a way of the way you do evaluation for that is you produce a program in virtual machine code, which when evaluated which when executed will have the effect of evaluating that expression. Now, the thing I want to tackle first of all in this is the way that we represent structured data. I want you to think about how we represent, in particular, how we represent numerical expressions. So an expression like 2 plus 3 times 4, or 2 plus 3 times v, where v is a variable. There are lots of different ways we might represent these things inside a computer. And one answer would be to say, well, we could represent them as a string. We could represent 2 plus 3 times 4 as the string, parenthesis 2 plus parenthesis 3 times 4, close parenthesis, close parenthesis. So it's one character after another. Why do you think that's a bad idea? You might like to stop here and think about that for a bit. I'll get started now. Why is it a bad idea? Well, when we look at a string like 2 plus 3 times 4, we don't look at it as a sequence of symbols. We see the structure that's in there. We see that it's 2, it's the addition of the number 2 and the expression 3 times 4. And we see that 3 times 4 is a multiplication of 3 and 4. So we see structure. So somehow we want to represent these expressions in the computer, in the program, as a structure. You can visualize that structure like this, that you have at the top, you have a plus, and then on the left, you have the number 2. On the right, you have another sub-expression, which is itself a multiplication of 3 and 4. So we somehow want to represent that kind of structure rather than representing a string of symbols. And the way we do it is like this. We use an algebraic type, and I've color-coded the various aspects of it so that you can see that the constructor add represents the addition at the top. And then there are two things below the addition, the things being added. On the left is something representing the number 2. On the thing on the right is a mul, which itself is a complex expression. Does this look familiar? Yes, it looks very like what we did with binary trees. So this is, again, this is something like a tree, but here this tree represents an expression in a small language, a language of arithmetical expressions. And here is our type for expressions. And what this type says is that there are 4 kinds of expressions. There is a number, which is represented by an integer. There is a variable that's represented by a character. And then you can add 2 expressions to make an expression, and you can multiply 2 expressions to make an expression. And so we've got a recursive data type here. We're explaining expressions in terms of expressions, just as we saw for binary trees. But here we've got these 4 different kinds of things: a number, because we see numbers in expressions, we see variables, we see the addition of 2 expressions and the multiplication of 2 expressions. Now, there are processes of going to and from strings to expressions. The process of going from a string to this structure, add number 2 and multiplication, is called parsing. And what that does is it uncovers the structure that's in that string. So it's got more information there. Just looking at that, you know that at the top level it's an addition. Whereas looking at the string, you've got no idea until you uncover the structure. So we will talk at the end of this masterclass a bit about parsing. On the other hand, what's called pretty printing, or just printing, is going from this structured object, this add of num2 and multiplication of 3 and 4, to the string, parenthesis 2 plus parenthesis 3 plus, etc., 3 times, etc. And that's called pretty printing. So we talked about various things we might do on expressions like evaluation and simplification and compiling. We can add 2 more things to that of converting expressions to and from strings. So we're building up a repertoire of things that we might want to do with expressions.